So good afternoon to all. Am I audible you? Am I audible?
Yes, sir, you are audible.
Kumar. So today I'm going to take your lecture for engineering mechanics and I will solve some numerical based on the support reactions. So all of you are required to raise your doubts if you are having in this particular chapter how to calculate the support reactions. So I will discuss 3 to 4 numericals in this particular class involving different types of loading. Okay, so anyone having any doubt regarding this particular chapter, so you are required to discuss with me. So just I am starting. I am just observing at present only 20 students are there, around 19. So all of you are required to convey the message that be on time in every class. So just wait, I am sharing my screen. So first of all, I am going to discuss this particular problem. Is this visible to you all, the slide?
Yes, sir.
Yes, sir.
Okay, so you are required to bring your calculator and copy. So because we are required to do the calculation in this particular class itself, so all of you are required to bring your scientific calculator and your copy, and you are required to do the calculations along with me. So in this particular case, the language of the problem is, as you can observe that there is one object which is rectangular in nature extended from point A from here to the point B to this particular point. So I think all of you know that this type of member whose longitudinal dimension is very large, this is the longitudinal dimension as you can observe, whose longitudinal dimension is very large as compared to its lateral dimension, supported along its length, and which is used to carry the vertical load over its length. That particular rectangular member is basically known as beam. I think all of you are familiar with the definition of the beam. So the beam is loaded, as you can observe. This is the loading number 1, which is triangular in nature. So again I am repeating, whenever a load is of the triangle in nature, then this particular type of load is basically known as UVL, uniformly varying load. All of you are familiar with this type of particular load. Why this is uniformly varying? Because if you consider this particular point, there is no load at all. Once you move towards left side, the load is continuously increasing, and if you join all these extreme points, so all these extreme point will lie on a particular straight line. That is why this word is over here, uniformly. Why it is varying? As you can observe, this is having the magnitude different at all the locations. That is why it is known as varying, as well as it is a kind of force. That is why it is known as load. So this particular beam is subjected to different types of loading, as you can observe over here. It is very obvious and you can easily visualize it. So 3 types of loading are there in this particular beam. So one is this particular UVL. So I am just doing the nomenclature. Let this particular point I am marking as L. Let this particular point I am marking as O. Let this particular point I am marking as M. So first of all, if you consider the triangle OAL, if you consider the triangle OAL, so this triangle is a kind of UVL. Now, I think all of you know that how to calculate the total load of UVL. What is the method? Method is just calculate the area of that particular load diagram. So area of triangle OHL you are required to calculate, which is nothing but half. After that you are required to multiply by the base, which is 4. After that you are required to multiply by the height, which is 2. As you can observe over here, it is clearly written that it is 2. So just if you do the calculation, 2 will get cancelled out and you are left with 4 kilonewton. So load of this particular triangle is, how much is the value? 4 kilonewton. It is very obvious that it will act in the vertical direction. Now the problem arises where this particular load will act. That is the main problem. So I think all of you know that the weight always passes through the center of gravity. As far as the right angle triangle is concerned, this is the right angle triangle, as you can observe. So if you recall the formula for center of gravity, if you are moving from 90° from over here, then you are required to move a distance which is equal to base by 3, and you are required to move perpendicular distance which is height by 3. The point at which you reach is basically the center of gravity of this right angle triangle. So this is how you are required to calculate the center of gravity. So total load will pass through the center of gravity. So you are required to apply the total load through the center of gravity. Once you extend, it will gets applied on this particular beam. So it will be acting at a distance of base by 3 from 90° right angle. If you are moving from here, then it is very obvious total distance is b. This is b by 3, so this will remains as 2b by 3. So it is up to you. If you are moving from the angular point, then you are required to move a distance of 2 base by 3, and if you are moving from right angle, then you are required to move a distance of base by 3. So now in this particular case, as right angle is over here at point A, so we are going to move from point A towards right, means in this particular direction, and the distance will be nothing but base by 3. So base of this particular triangle is 4, so 4 by 3 you are required to calculate. So if you do the calculation with the help of calculator, all of you are having the calculator, the answer will come out as 1.333. So you are required to move along the right side a distance which is equal to 1.33, and after that you are required to apply this particular load which is 4 kilonewton. So what you are required to do when you are going to solve such type of problems, first of all you are always advisable to extend the extreme points in this particular fashion, so that we can draw the diagram just below it, so that all the distances are properly marked. So this is the extension of all the extreme points. So one is the right side extreme point, another is the left side extreme point. After that I will represent the beam AB by the line diagram. So this horizontal line is representing, just wait, this horizontal line just representing the beam which is A over here, which is B over here. So this is the beam which is represented by AB. After that, first of all, I am talking about this particular load. So to mark this particular load, you are required to move a distance which is nothing but 1.33. So from here, you are required to move 1.33, reach a point and apply the load which is 4 kilonewton. So this is how. Now this is the intermediate point. Just draw this intermediate point. Total distance is 4, as this is 1.3 from here. So this distance you can easily calculate by subtracting from 4. So 4, just do the calculation, 4 minus 1.33. It will come out as 2.67. So mark the distance 2.67 over here. You are reaching at this particular point, which I am representing by O. Now you are easily visualizing that one point load is also acting at this particular point, so extend this particular point also. So let this is represented by the symbol of P. So you are required to mark the point load as it is, no need to convert this one. So this is already 10 kilonewton, so mark this load as it is 10 kilonewton. After that, just observe this particular triangle. Again, you are required to calculate the total load, which will be nothing but area. So area will be half. Again, the base as you can observe is same 4. After that, height is again you can observe it is 4. So if you solve this particular expression, 1 by 2, 4 into 4, the answer will come out to be 8 kilonewton. So you are required to apply the 8 kilonewton load. Now the problem arises where? So again, this is the right angle. So from right angle, you are required to move a distance which is base by 3. Base is same 4. So 4 by 3 will come out as 1.33. So as this particular distance is 2, so somewhere here you are required to apply this particular load which is 8 kilonewton, provided particular distance is your 1.33 and total distance from here to here, as you can observe, is 2. Total is 4. So this particular distance from O to P will remains as 2. So this is 2 meter, this is 2 meter, this is 1.33 meter, this is 2.67 meter, and this is 1.3 meter. Now the question says that you are required to calculate the support reaction. So in this particular case, you can easily observe that At point B, the roller support is there. So in case of roller support, always one reaction gets generated, which is perpendicular to the plane over which roller moves. So roller is moving on this horizontal surface. So reaction will get generated, which will be vertical. So this reaction you are required to calculate. It will be represented by RBY. Reaction at B in Y direction. Now focus on this one. This is the graphical representation of your hinge support. So this is a kind of hinge support. Graphical representation of hinge support. In case of hinge support, you are required to mute your mics. All of you are required to mute your mics. So at point A, there will be two reactions. One will be vertical, which is represented by RA, and another will be your horizontal, which will be represented by RAX. So this is how this particular diagram is drawn, and this particular diagram is known as free body diagram of the beam. So up to this particular point, if any one of you facing any doubt, then you can discuss very quickly. Any one of you, if facing any doubt up to this particular point, you are required to point it out. Very quickly, just tell me if you are facing any doubt. Any doubt to any student? Because next question you are required to solve by turning on your cameras. So you are required to tell me very frankly if any one of you facing any doubt regarding this particular free body diagram. Just I am clearing the space so that we can do the further calculations. Okay, so
Sir, could
as
you
you are,
confirm the answer?
okay, so just this is the answer. Just observe. I have mentioned the
Yes,
reaction
sir, exact
at
answer.
A. Are you getting these answers?
Yes, sir, exactly.
Okay, okay, then very good. So you are having the concept. Okay, very good. Rest of the students are also required to do this particular question. I am just trying to explain
Sir,
you.
I'm getting little bit difference.
So I think you have not considered all the digits after the decimal. That's why your answer may be
Sir, I
approximately.
take up to two और decimal के बाद 2 digit तक लिया है.
That is why your answer is not coming out to be exact, as you are allowed to use your scientific calculator, this type of calculator in your
सर
exam.
यही use कर रहे हैं.
But you are required to do the calculation in one go without doing in steps. So if you do the calculation in one go, then you are required to take the decimal of digits of after the decimal as 10. So if you consider all the digits after decimal, then you are required, then you will get the required answer, which is written over here.
Okay, sir.
Okay, so you are required to do the
7.166.
calculation in one go. So any one of you having doubt regarding this particular question, then you can ask. Otherwise, I will move to the solution part. Okay, as no one is having the doubt, it is clear to you all. So I am moving to now to the solution. As you can observe now that this particular beam is not moving in any direction, it means that the beam will be considered under equilibrium as the force system which is acting on the beam. As you can easily observe, this force system is nothing but coplanar. Why this is coplanar? Because all the forces are acting in the single plane, which is xy plane, and the force system is non-concurrent also, non-concurrent. So the equilibrium of coplanar and non-concurrent force system is basically analyzed by applying the three equations. One is summation of fx as 0, another is summation of fy as 0, and third equation is summation of moment as 0. So you are required to apply all these three equations. So first apply this particular equation. So in this particular case, you can easily visualize that on the left hand side, you are required to add all the forces in the x direction. So the only force which is acting in the x direction is Rax, no other force is there. So on the left hand side, Rax will come into the picture, right hand side is 0. So the value of Rax will come out to be 0. So it is very clear from this particular analysis that as you are not applying any action in x direction, all the actions which are in the form of weights this particular action is weight, this particular action is weight, this particular action is weight. All the actions are acting in the vertical direction. Hence, according to Newton's third law, reaction will also gets generated in the vertical direction in upward way. So that is why it is automatically coming out to be 0. So either mark it or not, in this particular diagram there will not be any effect. So by simple observation, when you are drawing the free body diagram, you are required not to mark this one. If you are marking, then you are required to equate it to 0, so your answer will come out to be 0. So by simple observation you can predict that Rax will come out to be 0. Now you are required to apply summation of Fy as 0. Before you apply summation of Fy is 0, always you are required to emphasize on the sign convention. I think all of you are considering upward force as positive and downward force as negative. So you are required to mention the sign conventions also. So now in this particular case, as you can observe, Ray is in upward direction, so plus Ray. This Rby is also in upward direction, that is why plus Rby. This is downward, so minus 4. This is also downward, minus 10. This is also downward, minus 8 will come out as 0. No other vertical force is there. So from here, if you substitute the values and rearrange them, so Ray plus Rby will come out as 22. So this is the expression number 1. Both are unknown, so we can't proceed further. So most important equation which you are required to apply is summation of moment as 0. So now it is up to you. You can apply the moment about any point. You can apply about point A, you can apply about point this one. You can apply about point O, you can apply about point P, you can apply about point B. But it is always advisable to apply the moment about the supports. Why about the supports? Because once you apply the moment about the support, one of the unknown will become 0. It will not contribute to the moment at all. So always remember, if you are not having the idea, always this moment equation you are required to apply about the supports. So either you are required to apply about point A or about point B. So I am applying over here about point A. After that, again you are required to mention the sign convention. So as far as my methodology is there, I always considered the anti-clockwise moment as positive and clockwise moment as negative. Reverse is also true. You can consider anti-clockwise as negative, then clockwise will be positive. So I will consider my sign convention, that is anti-clockwise positive and clockwise negative. So just observe over here. You are taking the moment about point A. Force Ray is passing through A. Its moment will be 0. Rx is passing through A and it is also 0. So this force will not contribute. This force will not contribute. So you are left with first force is 4. Perpendicular distance is 1.33. It is very obvious. The direction will be your this one, and which is your clockwise. So clockwise I am just considering as negative. So just I am writing down over here minus 4 multiply by 1.33. After that, you are required to move the force number 2, which is this one 10. Now perpendicular distance, as you can observe, this whole distance is 4. This is 2, so distance will be 6. So it will again move in the clockwise direction, so minus 10 into 6. After that, this is the 8. Again, it will try to rotate in clockwise direction. Now total distance will be up to this particular point is 6. And this particular distance you are required to calculate. So this will be total is 4. So this will be 2.67. So it will come out as minus force is 8. Perpendicular distance will be, just I am subtracting 1.33 from 8. So 8 minus 1.33. This is the perpendicular distance. After that you are left with Ray. Now the rotation will be your anti-clockwise. So plus Rby multiply by the perpendicular distance, which is the whole distance, which is 8. So you are required to equate it to 0. So from here just you are required to calculate Rby, which will come out as 14.8. Once you substitute the value of Rby over here, then you will get the reaction Ray as 7.2. So now it is open for discussion. This lecture is open for discussion. If you are having any doubt, then you can discuss to me. Any student having any doubt?
Excuse me, sir.
Yes.
Sir, actually, I got the exact answers, but sir, I only used the moment equation and I got the answers. I didn't use fx summation and fxy summation.
That is also correct. Once you are required to take the moment about A, after that you can take the moment
Yes, sir.
about point
About
B.
P. Yes, sir.
That is also correct. These three equations are applicable. Depending upon your convenience, you can apply and you can solve. So you can apply this moment equation only, then you will also get the answer. Once you calculate the moment about point A, after that you can calculate the moment about O, or about this particular point, or about this particular point. It is up to you. So if you are applying summation of moment about point A as 0, so you will get the value of RBY, because only unknown remains as RBY. Once you apply the summation of moment about point B as 0, so RBY will not contribute to the moment, so only RAY will contribute, so you will get the value of RAY. Again, this is the correct way. But in this particular fashion, when you are calculating the moment, I think you will take more time as compared to when you write it down summation of Fy as 0, because you have to write it down all the forces, and you are required to multiply by the distance, so time consumption may be more. So it is totally depending on you how you are going to solve. So absolutely correct way, no problem. Any other student having any doubt? So I think it is clear to you all. So I am moving to another question. You are required to draw the diagram. Just wait, I am just clearing this particular figure and then I am moving to another problem. Just wait, I am sharing once again. So now you are required to solve this particular question very quickly. Just I am giving you the 10 minutes time. All of you are required to draw this particular question on your copy. Take the help of calculator and try to solve it. Just giving you 5 or 10 minutes time. After that, I will see the copy of students randomly. So just try to proceed it. You all are having the 10 minutes time. So it is right now 12:38. At 12:48, I will check the random copies. So draw this diagram very quickly. After that, just solve it. Amit Kapoor, you are required to solve the question. Amit Kapoor, you are required to solve this particular question.
So can you show the questions once again?
Okay, just wait. I'm showing you. if anyone is finding any difficulty, then you are required to ask me regarding this particular question. So this is a kind of quiz. It will give you an idea whether you are understanding the concept or not. So do it very quickly. You are having 6 minutes more time. In this particular time, you are required to solve it. Three minutes more. After that, you are required to show me the work. Okay, Amit Kapoor. Amit Kapoor. Okay, I think he's not attending the class, not responding. So, CR of this particular group, kindly convey the message. He will be marked as absent for today's class, not responding from the very beginning of the class. So,
Sir,
CR
he's
of this
not in our batch.
not in your batch.
No, sir.
Okay, so he is in this particular class. So I am removing him from over here.
सर ये क्लास अटेंड करता है बट हमारे बैच में नहीं है.
So, so just I removed him. After that, Aditya Rajput, just show me your progress. Have you done anything regarding to this particular question? Aditya Rajput.
Yes, sir, I will post it in general.
Okay, so you are required to post it in the chat box. After the end of the class, I will see it up. So you are having the time after the class within 10 minutes means
Yes,
up
sir,
to
I'm
one.
posting it.
Okay, So up to 1:30, all of you are required to post this particular question on your chat box. Okay. So now I'm open for discussion. After that, I will move to the one more problem related to friction. That is very interesting problem. I will solve it up with the help of angle of friction concept. So as far as this particular question is concerned, if any one of you having any doubt, then you can discuss. Neha,
So
go
what is
ahead.
the
Is there
answer
any
for
doubt?
this?
Yuvraj, yes, tell me.
So what is the final answer if you could confirm?
Final answer, I will post it in the group after this particular class. Okay.
Okay. Okay.
So just right now you are required to try. I am intentionally not posting because otherwise some of the student will try to hit and trial and get this particular answer. So you are having the time up to 1:30. You are required to solve it and post it in the group. After that, I will post the answer in this particular group itself. Then you are required to check. So very quickly, I'm again asking if any one of you having any doubt, then you can discuss. Otherwise, I will move to one more problem related to friction. Nikita Sharma, is there any doubt? Nikita Sharma.
No, sir.
Okay, Nibir. Nibir, is there any doubt to you as far as this problem is concerned?
No, sir.
Okay, okay. One more. Hiren Sahani, is there any doubt?
No, sir.
Okay, so I'm just unsharing this particular slide and I will move to one more problem, very interesting problem. We will solve it with the help of concept of angle of friction. So just wait, I'm attaching the slide. I think now it is visible to you all. So just we will solve this particular problem with the concept of angle of friction. So just focus on the language of the problem very quickly. So in this particular question, it is said that a horizontal force of magnitude capital P, as you can observe, this is the horizontal force of magnitude capital P is applied on a 50 kg block. So this is the block which is placed over this inclined plane, and this block is having the mass as 50 kg. So you can easily convert this particular mass in the form of weight. So you are required to multiply 50 with the help with G, which is your 9.81. So you can easily get this particular value 50 multiplied by 9.81. All of you are having the calculator, so it will be some Newton. So this is required when you draw the free body diagram. Now this is placed on an inclined plane as shown in the figure. So this is the figure which is given to you. Inclined plane is having the angle of 40 degree with horizontal. Now you are required to answer in first case what will be the value of P. So now just read very carefully part number 1. To just push the block up the incline means this P you are required to apply on this particular block such that you are required to just push up the inclined plane. So word is just push. It means that this is the problem related to impending motion. The block is not moving at all. You are required to just push it up. So the motion is about to begin when you apply this particular force. So this particular condition is basically known as you already know that this particular condition is basically known as impending motion condition. Now under this impending motion condition, the friction force which acts on the contact surfaces has the maximum value, which is represented by either Fs max in some of the books, or in some of the books it is mentioned as limiting force of friction, and in some of the books it is mentioned as maximum static force represented by Fs. So all the representation you can find it out what is the maximum value, which is governed by this particular formula mu s into n, where n is the normal reaction. So as you all know that whenever impending motion is there, force of friction will be maximum and it will be governed by this particular formula FL or Fs or Fs max as mu s into n. So you are required to analyze this particular problem. As we are talking about impending motion, it means that you are required to solve this particular problem by considering the equilibrium of the block, because during impending motion the block is having the tendency to move, but it is not moving at all, it is on the verge of motion. So equilibrium conditions we are required to apply to solve it. So there are number of methods by which this equilibrium can be analyzed. I will discuss one by one once we draw the free body diagram. So first of all, I am focusing on how to draw the free body diagram of this particular block. So first force as it is you are required to apply, which is external force P. After that you are required to find it out its center of gravity. Let this particular point is center of gravity. Through the center of gravity your weight of this particular block will act. So this is the weight of the block which is acting, which is nothing but 50 into G. After that, as the impending motion you are required to create in upward direction along the inclined plane. So it is very obvious limiting force of friction, which is represented by either FL or Fs max, will act in this particular direction. So this will be Fs max, which will act on the contact surface of the block in the downward direction. Now as the block is having contact with your inclined plane, so very obvious you are required to apply the normal reaction on this particular block. So this is the normal reaction which will act on this particular block. From the very basic knowledge of trigonometry, if you draw the vertical line like this one, as this is 40, this is 90, so this has to be 50, so this will be your 40. So this angle will come out to be 40 from the basic knowledge of triangle. This is 90, this is 40, this will be 50, so this will be 40 because this is perpendicular to the inclined plane. Now as you are discussing about the equilibrium, so one of the conventional method is whenever equilibrium is there, you are required to apply summation of fx0, you are required to apply summation of fy as 0. So if you apply these two conventional equation over here, then the process will become very lengthy, because first of all, when you apply summation of fx as 0, you are required to resolve this particular force in x direction as well as in y direction. This particular force you are required to resolve in x and y. So in place of this particular set, some of the student may apply summation of forces. Number of ways are there. Along the inclined plane as 0, this is also correct. Summation of forces perpendicular to inclined plane as 0, this is also correct. So now in this particular case, if you apply, so this particular force is neither along the plane nor perpendicular to it, so you are required to resolve it. Similarly, you are required to resolve it. So process will become little bit lengthy once you apply this conventional method. So I am not going to apply this conventional method. So I will move to some interesting method, that is with the help of angle of friction I am going to solve it. So now focus on this particular force which is Fs max and this particular force which is N. So these two forces, as you can observe, both the forces are coplanar and concurrent. Why concurrent? Because both of these are passing through this particular point. So from the very basic knowledge, you already know that whenever two forces which are concurrent and coplanar acts over a particular body, so the resultant of these two forces you can easily find it out with the help of parallelogram law. What you do in parallelogram, just extend or draw the line parallel to first force from second one. From the second, you are required to draw the line parallel to first one. So this is how parallelogram is drawn. Now the diagonal which is passing through the point of concurrency, which is this one, will give you the value of resultant. So now it is very clear, resultant will lie in between these two forces somewhere. So that will be governed by this particular direction alpha. So now what I'm going to do over here, one force is your Fs max, another force is N. So I'm going to find it out the resultant, as the resultant is in between these two forces. So just I am marking this particular force as the resultant of these two. So Fs max and N can be replaced by this resultant force. Now if you recall the definition of your angle of friction, the angle of friction is nothing but the angle between normal reaction and the resultant of normal reaction and limiting force of friction. So this particular angle is always defined as angle of friction, represented by phi s. I think all of you are having the knowledge of this particular concept, how to represent the angle of friction. If you are not having, then you are required to remember like this one. Always remember, the angle of friction is nothing but the angle between normal reaction which is this one. In our case, normal reaction is this one, and the R. What is R? R is the resultant of limiting force of friction and normal reaction, which will be somewhere in between these two. So this is the way by which these two forces can be replaced by the resultant force R. Now you can easily observe that this particular block is under the influence of three forces. One force is 50, another force is P, another force is R. Now you are not required to consider this one. You are not required to consider this one. So this system is reduced to three force system. Now under the three force, if the body is under equilibrium, so now you can represent these three forces by the sides of the triangle. So triangle you can easily draw with the help of these three forces. So what you are going to do, first force, let first force is 50G. I am drawing in as it is in the required direction. So this is the force number 1, which is for 50 multiplied by G. Very quickly I will going to solve it. After that, second force is P, which is acting in the horizontal direction. Apply as it is. This is P in the horizontal direction. Now it is very obvious that the closing side will give you the third force, which is your R. So this is how you are required to draw the third force, which is R. Now mark the angles very carefully. Now this is the R, as you can observe. This is the vertical line. So R is making the angle with vertical as 40 plus phi s. So this particular angle of R with vertical will come out as 40 plus phi s. Now this is 90. Sum of all the angles of a triangle is 180. So if you calculate by this particular property, this particular angle I think will come out as 50 minus phi s. So if you add all these three, you will get the answer as 180 degree. So very easy. This particular angle is 40 plus phi s. This particular angle will be 50 minus phi s. This particular angle will be your 90 degree, as you can observe. Now you are required to find it out the value of P. So very easy. In this particular triangle, you are required to apply the sine rule. Once you apply the sine rule in only single step, you will get the answer. So now just I am going to apply the sine rule. So 50G, which is this particular force, divided by sine of angle between other two sides. So other two sides are R. The angle between them is 50 minus phi s. So sine 50 minus phi s will be over here is equal to, as you are required to find it out, P. So I will consider P divided by sine of angle between other two forces. Other two forces are 50G and R. The angle between them is 40 plus phi s. So sine 40 plus phi s. So if you compare these two, this is known to us. Now the problem is how to calculate the value of phi s. Once you get the value of phi s, then you will get the value of P. For that, it is very simple. All of you, I think, know the formula. Mu s is always represented as tan of phi s. Now mu s is given to you as 0.2. So just 0.2 is equal to tan of phi s. Once you take the tan inverse, phi s will come out, I think, 11 point something. You are required to calculate it exactly. I think it will come out, I don't remember the answer. I think it will come out as 11.31 degree. So once you know the phi s is also known, substitute over here, you will get the value of P. So very quickly you are getting the answer. But if you go for conventional way like this one, you will face very difficulty. Why difficulty? Because the time consumption is very much as compared to this one, and at least 1.5 page is required to solve by conventional method. So it is always good to proceed the problems of friction by different methods depending upon the situation. So now you can discuss if you are having any doubt regarding to this particular solution. Very quickly you are required to discuss. Any one of you? Just tell me, are you facing any doubt regarding this particular solution? Just wait. Yes, anyone having any doubt? Kusagr Jain, is there any doubt regarding this particular problem? Kusagr Jain.
No, sir.
Okay. Sahil Jain. Is there any problem regarding to this
No doubt,
particular
sir.
problem? Is it clear?
Yes, sir, it's clear.
Okay. Vansika Jain, is there any problem? Vansika?
No, sir.
Okay. So as far as the systematic solution is concerned, just observe, I'm now focusing on the systematic solution. So this is the solution of this particular problem. As you can observe over here, I have already discussed all the points. So this is the shortcut method. Very quickly you can get the answer. So now if you are understanding this particular concept, so now you are required to focus on the part number 2. In part number 2, just what is going to happen, now you are removing this particular force P. Now what you are going to do, again you are applying the P, but now the condition is just prevent motion down the inclined plane. Means this particular body is having tendency to move in downward direction. So we can say that impending motion is occurring and it is going in the downward direction. Again, the problem will be solved by considering impending motion, but now impending motion is downward. So you are required to apply the force P such that this impending motion can be prevented. So a small amount of force as compared to this one you are required to apply, because this is the force which is required to move this particular block in upward direction. Now just you are required to hold it up, so the force will come out less than this one. So only modification will be the force is having tendency to move in downward direction, so your limiting force of friction now will act along up the plane like this one. So this is your Fs max over here. After that, normal reaction will be exactly same which you already apply. So this is the normal reaction now represented by N. Now somewhere in between these two will be the resultant of these forces. So let this is the resultant which is represented by R. Now the angle of R with normal reaction is always defined as angle of friction, which is phi s. So this will be your phi s. Now if you draw the vertical angle like this one, vertical line, so N with your vertical will make the angle of 40 degree. Previously we have already discussed that the angle of N with vertical, as you can observe, the angle of N with vertical is 40. So total angle from here to here is your 40 degree. So from here you can easily conclude that the R will make the angle with the vertical, which is this one, as this particular angle will be 40 minus phi s. So this is the only modification. In previous case, the angle made by the R with vertical was 40 plus phi s. Over here, the angle made by R with vertical will be 40 minus phi s. So this is the modification. Accordingly, you are required to draw the free body diagram. So one force is remaining to mark over here, that is the weight. So weight will be your 50 multiplied by G, another will be P, and last one is the R. So accordingly, you are required to draw the triangle once again. Now the only modification which is going to happen is this will be vertical as it is, it will get applied. This is horizontal as it is, you are required to mark. Now this is the R exactly you are required to mark, but the angle will get changed. Now the angle of R with vertical is 40 minus phi s. So this particular angle will not be 40 plus phi s. This will be 40 minus phi s. Accordingly, this will get changed. This will be nothing but 50 plus phi s over here, because total sum has to be 180 degree. So that is the simple modification over here. If you again apply the sine rule, which is this type of rule, so you will get the answer for P. Obviously it will come out less than the previous value, which is 612. So you are required to solve it up very quickly. So just I'm moving to another slide which is showing the solution of this particular problem. This is the way. So this is the solution. Now very quickly you are required to ask if you are facing any doubt. So answer is coming out to be 268.43. I think if you are doing the practice, hardly it will take 2 to 3 minutes to solve. But if you proceed by conventional way, that is summation of fx0, summation of fy0, or summation of forces along the plane and summation of forces perpendicular to plane, then it will take the time, at least it will require 10 minutes time. So if you are doing the examination or attempting the examination, so it is always advisable to follow shortcut methods. So this is a kind of shortcut. If you use the concept of angle of friction, anyone having any doubt regarding this particular problem? Anyone having any doubt regarding this problem?
सर स्टेप वाइज अगर करने को कहा हो तो भी चलेगा ये तरीका, मतलब मार्क्स वार्क्स नहीं कटेंगे?
No marks will get deducted. This is the standard method. No need to follow summation fx0 fy0 in all the places. In some of the places you are required to judge yourself how to proceed it very quickly. So this is the way by which you can proceed it very quickly, and that is how we solve the problems. As far as the my section is concerned, I have already clearly mentioned to all the students that depending upon the situation you are required to apply a particular concept. So I am also taking this particular subject in other sections. So I am solving all the problems by this particular method as far as friction is concerned. So this will give you very quickly the answers. Okay. So I think right now we are not having much time. So just wait, I am downloading the attendance and just I'm stopping the recording. So you are not required to leave right now.